Hello everyone. So today we are going to discuss problem of the day from the Greeks or Geeks. Stock buy and sell, multiple transaction allowed. This is a hard level problem and it has been asked in so many different companies. So let's see the question. The cost of stock on each day is given in an array price. Okay. Each day you may decide to either buy or sell the stock at a price I. So basically there is an array which tells you the price of these stocks on the ith day. And you can even buy and sell the stock on the same day. This is also an option. You can buy and sell the stock on the same day. So suppose the price of a stock on a day is $10. You can buy at $10 and you can sell at $10. Well, profit and loss for that particular day for you would be zero in this transaction while buying for 10 and selling for 10. Okay, we'll come to that. Find the maximum profit that you can get. So you basically have to find out the maximum profit that you can get. Okay. Here's an important note. A stock can only be sold if it has been bought previously. Obviously, you can sell a stock only if you have it. And to have it, you previously have to buy it. Okay. And multiple stocks cannot be held at any given day. So let's see the example. So this is the input example where the prices of the stock first rise. Okay, then it goes down, then it rises and rises. Okay, as you can see from the graph, goes up, goes down, and then goes up. In order to gain the maximum profit, one should buy at this price and sell at this price just before falling down, right? And then he should buy at this price and sell it at the highest price possible. Okay, so that's how he can maintain the maximum profit. And here the total profit would be 210 plus 655 gives you 865. How do we approach this problem? We have got prices of our stock. On the ith day, the price of the stock is prices of I. Okay, so our day basically starts with 0, right? Because the array follows the 0 based indexing. So we will say that our day starts with day 0. Yeah, and it goes up until day n minus 1, right? Because if the size of the array is n, the last day that you have is n minus 1 of the day. Each of these days, in each of these days, what you can do, you can buy the stock or you can sell the stock. Yeah, or you can just hold the stock. So there are three options for you every single day. You can buy, you can sell, or you can hold. These are the three options that you can have. Holding means basically doing nothing. You neither buy, you neither sell. Now, it also said that you can buy and sell it on the same day, right? You can even buy and sell the stock on the same day. Now, let's think about this statement. You have to maximize the profit. Now, why will you buy and sell on the same day? I gave you an example at the starting. If you buy a stock for $10 and then you sell it for $10 on the same day, does it make any profit? The answer is no. So why is that transaction necessary? Why buying and selling the same day? If the price of that particular stock is going to remain same throughout the day, it makes no sense to buy and sell the same day because the profit generated from there is zero. So buying and selling the same day is not an option. So every day you either buy or you sell or you hold. Okay. Since we have got only these three options, now let's analyze when can we use which option. Well, the option of holding, we can use it always. We can always just sit and do nothing. So option of holding is always there for you. Let's talk about when we can buy a stock and when we can sell a stock. Well, we can sell the stock only if we have previously bought a stock, right? You cannot sell something you don't own. You have to have previously bought it in order to sell it. And you can buy a stock only if you don't have a stock already bought with you. Because let's see what this statement says. Multiple stocks cannot be held on any given day. So if you have previously bought a stock, you have a stock already, you cannot buy it again on any other day. Okay, it means you will have not two stocks. Multiple stocks cannot be held. So if you have bought it previously, you can either sell it or just hold it. Okay, but you cannot buy another one. So you can buy it only if you don't hold any stock previously. Okay, and you can sell it only if you have already bought it previously. So for that, we need to have an indicator which tells us whether we have bought the stock previously or we have no stock bought, so we can buy it now. So these are the two options. We have the stock or we don't have the stock. These are the two options that we have. When we have the stock, we can choose to sell it and gain some money, or we can choose to hold it. Okay, we can choose to just do nothing that day. When we don't have the stock, we can choose to buy it on that particular day, or we can choose to just hold it and do nothing about it. Okay, so these are the options that we have. When you sell a stock, you basically get the money, right? What amount of money that you will get? You will get prices on that particular day, right? When you hold, you don't get anything, it's a zero. Now, when you buy something, you have to give the money. And how much money will you give? You will give prices. You are giving it, so I'm indicating it with a negative. What will happen to your wallet? It will either be credited or it will either be debited, right? It will be debited when you buy, it will be credited when you sell the stock. If you are holding it, nothing will happen, only the day will change. Now, to indicate whether we have the stock or we don't have the stock, we need something. So it says there are two options here. We can use a boolean to indicate that true or false, or we can just use an integer which can take up two different values. Okay, so in this case, I'm going to be using integer. Okay, you can use boolean as well. It's completely up to you. And I'm going to call that integer. Let's call it just flag. Now, if the value of flag is 0, I'm going to use it to represent this condition. I'm going to use this to represent the first condition that we have the stock and we can sell it. And if the value of flag is 1, I'll be using it to represent this condition that we don't have the stock. We need to either buy it or just do nothing, just hold it. Okay. So you see where this problem is going. At every day, we have got three options. So we have to try all the possible options, and out of all the possible options, we have to find the maximum profitable path. This is indicative of dynamic programming, where we need to look at all the possibilities. What are the different states of this problem will be? What is the thing that is changing? Well, first of all, it is a day, right? We need to create a function maximum profit. Yeah. So what is changing? Well, the day is changing, isn't it? And this condition is changing, whether we have the stock or we don't have the stock. Is there any other thing that's changing in this problem? Well, I don't see anything other thing that's changing in this particular problem. So this is the function that we need to write. Maximum profit, which takes in the day, and a variable flag, which tells you these two conditions. So how many total days that we have is the size of our array. The size of the array is, let's say, n. So this is the total number of day that we have. Since array is 0 based, we are going to say that our day is going to start with 0 and go till n minus 1. Okay. So if you come across that if day is equals to n, it means we have traversed through all our days. So what should the profit be now? Well, nothing. So just return 0. Okay. Now at every stage, we have three options: buy, sell, and hold. Okay. In hold, what do? We don't do anything, right? Our day changes and our wallet doesn't get an increment or decrement. Our wallet is neither debited nor credited. Just the day changes. We can write down hold as maximum profit and the day will change. The flag will not change. So if we have previously bought this stock, that stock will remain bought. If we have previously sold this stock and we don't have any stock, we don't have any stock. The second variable is not going to change. It's just the day that is going to change. So we need to add a +1 in the day. So day changes from day to day +1. Now let's discuss sell condition. Okay, we can sell the stock only if we have previously bought it, isn't it? Now, what is the condition? What is the value of flag if we have previously bought it? Well, we have this stock, we have previously bought it, the value of flag is 0, right? Then only we can sell, isn't it? So, the value of flag should be 0. So, we write the condition if flag is 0, then we can sell the stock, right? So the selling would be, well, selling will add a credit. If we have sold it at this particular day, this much amount will be credited in our account, and we need to find out the maximum profit from the remaining days in the market. Okay, so we'll just copy this up. Our day changes, and this flag will also change since we have sold it. We don't have any stock in hold, so we can buy it now. Since we can buy it now, the value of flag should now become 1, isn't it? The value of flag should now become 1. So I just write 1 in here. This is what I should write. Okay, else if the value of flag is equals to 1, it means that we don't have a stock in hold, so we can buy a stock on that particular day. So we'll say that buy is equals to, if we are buying, it means some money will be debited, it will get cut from our wallet, so it should be minus prices of that particular day, minus the price of that particular day. So we'll need to add this thing, right? And then I need to find out the maximum profit from the remaining days. And if we have bought it, it means on the upcoming days we can sell it. So I should change this 1 to 0. Remember the condition. If it is 0, we can sell it. If it is 1, we can buy it. Okay, so for the upcoming days, I'll change it to 0. Okay, and at the end, I'm going to return the maximum of buy, sell, or hold, and that is going to give me the answer. So it is a recursive approach, okay, and we can further memorize it in order to improve its time complexity. So let's code our approach. So we need to define the function that calculates our maximum profit. So let's define it over here. What were the parameters in that function? It was the day, and it was the flag which used to tell us whether we can buy or sell on a particular day. Now, how many number of days do we have? The total number of days is going to be the size of the array. Okay, and if the day becomes equals to n, we will returning 0. Now we have 3 conditions. We can hold, buy, or sell. So let's just initialize them with a very big negative number. The condition of hold would be the day will just change, the flag remains as it is. That's it. That's your hold. Okay. Now we check for the condition of selling. Remember, if our flag was 0, we were saying that we have the stock and we can sell it. So we need to sell the stock. So our sell will become the price on that particular day plus the maximum profit that you can generate from the remaining days. And the value of flag will now become 1, because when you have sold it now, what you can do is now buy it. You cannot further sell it. So the value of flag must change to 1. Similarly, if the value of flag is 1, you can buy it. Now when you buy it, it should be minus prices of day. And then you add the maximum profit from the remaining days. The value of flag should now become 0. When you buy something for the remaining days, you can sell it now, because 0 indicates that you are already holding the stocks. And at the end, we're going to return the maximum of the 3 values: buy, sell, and hold. So I'm just going to return the maximum profit starting from the 0th day. And what should be our initial value of flag? Well, our initial value of flag should not be 0, because 0 indicates that we can sell it, right? It should be 1, because 1 indicates that we can buy it. So initial value of our flag should be 1. Okay, and the other parameter is our array. Let's run and see if it works fine. Okay, it's a problem that I have declared the array nums instead of the array prices. So I'll just replace every nums with prices. Okay, now let's run the code. It is working fine. Okay, now if I go and submit it, it will not be accepted because we have not yet memoized it. We have not memoized our recursive solution, because this is going to lead to exponential time complexity, because we are trying every part out and many of the parts are repeated, and we should not be going through the repeated parts again and again. In order to avoid that, we need to memorize our code. Okay, so how do we memorize it? We do it by storing our answer in a vector. So let's declare that vector. We're going to call that vector dp. So when the main function is called, I'm going to resize this vector, number of days, and the number of different values that the flag can take. Okay, so it can take on two different values. Okay, so it's a 2D vector of n by 2. I'm taking n plus 1 just for the sake of best practice in order to avoid segmentation faults. Even if you take the size of the dp as n and there are exactly n different states, it's completely fine. Okay, and I'm going to initiate all the values in that particular vector as a value that cannot be our answer. So I'm just going to call it -1. Okay, so if you're trying to generate maximum profit, we for sure know that our maximum profit will not be -1, because even if you hold all the days, the profit that you're going to get is 0. Okay, so I'm just going to initialize it with -1. Okay, so all the contents of our dp is -1 and the size of it is n by 2. So here, before returning the answer, I'm going to first store it in our vector. So dp of day flag is equals to this. And before moving on to the code and further increase our recursive branches, I'm going to first check if we have already come across this state, if we have already come across day and flag. Okay, and if you have already come across it, this value will not be -1. So I'm gonna just return this value here. Okay, now let's run the code and see if it works. Okay, n was not declared, so let's just declare our n over here. Now let's run the code. Okay, it is working fine for this test case. Let's submit it and see if it works. It is working fine, right? So what's the time complexity of this code of ours? The time complexity of our code is going to be the different number of states that there are. So the value of flag takes up two different values and the value of day takes up n different values. Okay, so the time complexity is going to be 2 times n. So the overall time complexity, we can just say it's O of n. Okay, and similarly the space complexity is also O of n,